Day 229 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem. This time we're at day 209 and we're still going strong. Today we have question number 105, construct binary tree from preorder and inorder traversal. Excuse me. The difficulty level is medium, but don't worry, we're going to keep the solution as simple and easy to understand. So let's get into it. See what the question says. Question says, given two integer arrays, preorder and inorder, where preorder is the preorder traversal of a binary tree and inorder is the inorder traversal of the same tree, construct and return the binary tree. So I know that's a little difficult to understand just by reading the question. So let's look at example one so we can see what it is that they're talking about. So in example one, we have the input preorder, which is an array of integers 3, 9, 20, 15, and 7. Then inorder is also an array of integers 9, 3, 15, 20, and 7. The output is the binary tree that we are constructing, which is 3, 9, 20, 0, 0, 15, and 7. So we know that this picture is the picture of the output, right? Because we have the 3, which is the root, then we have the 9 and the 20, boom. Then the 9 is null on the left side and null on the right side. That's where the null comes from. And then the 20 has the 15 and 7, right? So we have to figure out how did they create this binary tree right here from these two inputs. And I'm about to show you how. So let's get into it. First thing, let me copy and paste this. Let me copy and paste this over here so I can show y'all, give y'all a better example, and copy and paste this as well so we can go through it, right? So right now we are trying to right now we're trying to construct the binary tree from the preorder traversal and the inorder traversal. In order to do that, first we have to know the difference between preorder traversals and inorder traversals. So the preorder traversal is a regular like a regular binary tree where we started the root, then we go left to right. So we started the root with a 3, then we come to the left, it's a 9, then we go to the right, it's a 20. Then these would be null, and then that's where the nulls come from, but they're not in the preorder integer array. And then the 20 would go 15 and 7. So that's where this preorder array of integers come from, right? It goes 3 at the root, then 9, then 20, then 15 and 7. Just going from left to right like this, but starting from the root. Whereas the inorder traversal is it's you traverse the first you traverse the left subtree, and then you process the root node, and then finally you traverse the right subtree, right? So the inorder traversal is we will start with the left subtree. So the left subtree we see is a 9, so that's where this 9 comes from. Then after we complete traversing the left subtree, then we process the root. The root is the 3, so that's where this 3 comes from because the 9 is the only value on the left subtree. And then we do the right subtree, right? And we do the same thing. It's the same order. We start from the left, which would be 15. Then we go to the parent node of 15, which would be 20. And then we do the 7, right? So it's the same thing. Like from here, we went from 9 to 3. When we're doing the left subtree to the root, it's the same thing over here. We started the 15, then we go to the 20, then we go to the 7, right? So that's how the inorder traversal works, and that's how the preorder traversal works. Now we need to figure out how we get this output from these two inputs. And knowing how these traversal works, we know that we have all the information that we need to um, complete this binary tree. So let me bring this over here so we can start. So with the preorder traversal, we know the preorder traversal starts with the root, with the 3, right? So that's where the 3 comes from. 3 is right here. We know preorder starts with the root, so we could just put the 3 right here. We know the 3 is going to be the root. Then we have to figure out how to construct the left subtree. Now we know that 3 is the root from the preorder traversal, and it's a 3 right here in the inorder traversal, which means everything to the left of the 3 is the left subtree from the 3. And then since there's only one value on the left subtree, it makes it pretty easy for us because now we know we just have to put a 9 right there, right? We know that a 9 is the only value. Excuse me, y'all. We know a 9 is the only value on the left subtree. Boom. So we come down here and we just put a 9. Now that we have the left, since that's the only value on the left side, we know that's the only value on the left subtree. Now we could work from and figure out how we're going to construct the right subtree. Now, so we come down here, let me get the tree going. So now we have to figure out how we're going to work with these values. Well, we go back to the preorder traversal. We know it's going to go, it goes 3, then we go to the left to the right, right? So it goes 3, 9, 20. So we know 20 is the next value and after 9 from looking at the preorder traversal, right? So we could put a 20 right here. My bad, y'all. Put a 20 right here because we know that the 20 comes after the 9 from the preorder traversal. Boom. So now we have the 20. Now we know that the Inorder traversal has the root, or it starts from the left side and then goes up to the 20 and then goes back to the 7, right? That's how the Inorder traversal works. So now we know that the 15 is on the left side of the 20. Boom, we can put the 15 right there. Boom. And we know that that means the 7 would have to come on the right side of the 20 because it goes 15, 20, then 7. So it goes 15, 20, then 7. That's how the Inorder traversals work. So then we just come over here. Oops, my bad. My bad, y'all. Come over here and we put a 7. And now we have constructed our binary tree. And we have to just remember that it's null over here when we are creating our binary tree. We know it goes 3, then 9, 20. Then we see these are the nulls, right? So it goes a null on the left side of the 9, a null on the right side of the 9, and then we come over here and it goes 15, 7. And that's what the output is. That's how we get an output right there, y'all. And that's how we figure out how to construct the binary tree from just looking at the preorder traversal and the Inorder traversal. So let's look at example 2 where preorder is -1, Inorder is -1. So the output is -1 because we didn't really have to traverse anything because there's only one value. So that's only going to be one node. Now that we understand the question and what they're asking us to do, let's get into the fun part, the part we all know and love, the actual code. Before we get into the code though, y'all, don't forget if you need any new Apple AirPods, go ahead and check that link out in the description. Then after you do that, go like, comment, and subscribe. Y'all, it doesn't take too long to like, comment, and subscribe. Just hit that like button, subscribe button, and drop a few bank emojis for me. Now let's get into the solution, y'all. So first thing we're going to do is we're going to check to see if the preorder array is empty. And if it is, then we're just going to return, or else if it's not empty, we're going to return nil. So in order to do that, we're just going to say guard preorder dot count is greater than 0, else we are going to return nil. So these brackets should be brackets, not square brackets. So boom, like that. Then we're going to come down here and we are going to check to ensure both arrays are not empty. So now we need to make sure neither one of the arrays are empty. And we are going to do that by saying guard exclamation point preorder dot is empty, comma, exclamation point Inorder dot is empty. Then we're going to say else return nil. And once again, that's going to make sure both arrays are not empty. Then what we are going to do is we need to see that we need to make sure that the root of the tree is the first element in the preorder array, right? So we know that the root is always going to be the first element in the preorder array. So that's how we're going to set the root right now by saying declare a variable called root. We're going to set that equal to tree node, parentheses, preorder, square bracket 0. So what this is going to do is it's going to start the tree node with the preorder with the index 0. Whatever is at index 0 in the preorder array, that's going to be the root of the tree node. Then we're going to come down here. Now we need to find the index of the root node in the Inorder array. So in order to do that, we're going to say if let index equals Inorder dot first index open of the parentheses of colon preorder square bracket 0. So once again, this is going to find the index of the root node in the Inorder array, right? So this the Inorder array, we're going to find which index is the preorder 0, right? Boom. So it's going to check that right there. Then we are going to come down here. We're going to say if the index is greater than or equal to 1, this means there are left child nodes, right? So that means now we have to check for that, and we are going to do that by saying if index is greater than or equal to 1, just like that. Then we're going to open up the brackets, and now we're going to recursively build the left subtree using the left part of the preorder and Inorder arrays, right? So in order to do that, we're going to say root dot left equals build tree, which is some recursive from up here, and we're going to open up the parentheses. We're going to say array, open up the parentheses, preorder, open up the square brackets, 1 dot 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 index. And what that is going to do is it's going to check the preorder the left part after the root before the index. So we're going to do it like this. Boom. Now we have to do for the Inorder. So we're going to say array, open up the parentheses, Inorder, open up the square brackets, 0 this time, dot dot up to index. Boom. And sorry, y'all, put a comma right here. Then we're going to come down here and we're going to recursively build the right subtree using the right part of the preorder and Inorder array. So this right here is how we build the left subtree. Now we have to build the right subtree, and in order to do that, we're going to come right here. Excuse me. And we are going to say, come over here because we're, well, hold on, sorry, I should have put the brackets right here on this if. So we can put this right here. Add a bracket down here. So now we are still inside this if statement, but outside of this if statement. This if statement was for the left side of the subtree, the left subtree. Now we're going to build the right subtree. And in order to do that, we are going to say root dot right equals build, it's going to be build tree, open up the parentheses, and we are going to say array, open up the parentheses, preorder, open up the square brackets, index plus 1, index plus 1, up to, or excuse me, yeah, up to preorder dot count. Now we're going to come off side of that, put a comma, and we're going to say array, open up the parentheses, Inorder, square brackets, Inorder, square brackets, index plus 1 up to Inorder dot count. And then we're just going to come down here and return the constructed tree with the current root node by saying, so we're going to come underneath right here outside of this if statement, or outside both of these if statements, and we are going to say return root. Now let's run it. See how that runs. Make sure it runs how it's supposed to. Okay, we got a typo. That should be build tree, I think, not built tree. Sorry about that, y'all. Build tree. So let's run it again. See what happens this time. Okay, so now can I find Inorder? Sorry, this should be Inorder. Let's run it again. We're getting there, almost there, and it's accepted, y'all. So now let's submit it. Make sure it stays accepted after we submit it, and we will be done for the day. Let's see. Okay, 19 milliseconds beats 45.95% of users with Swift. Not too bad, y'all. We're not too worried about the numbers right now. This was a pretty tough question to even understand. So we just want to make sure that we can complete the question and come up with a solution that answers the question, y'all. So we're not going to worry about the time complexity. We'll worry about that as we get further down our LeetCode journey when we become more comfortable answering these questions. Right now, we just want to be able to get the question answered, and we did that. We accomplished our goal for the day. I hope y'all learned something, and I hope to see y'all here tomorrow for another day, another LeetCode problem. Oh yeah, before we leave though, get one more look at the code if y'all need one more look at the code. One more look at it. That's it. See y'all tomorrow.